There's a special rule that combines multiplication and addition. We're going to find that rule by counting these little squares. Now there are a couple ways we can count these squares. We can count the squares over here, count squares over here, and then add the two. Or we can see that we can fit these two rectangles together nicely. Make a larger rectangle, and then we'll just count the little squares in the larger rectangle. So now let's go ahead and do both of these counts. This little rectangle over here has 2 columns. Each column has 3 squares. That's 2 times 3 little squares. Over here we have 5 columns, each with 3 little squares. That's 5 times 3. So the total number of little squares up here, we just add these two. Now coming down to the big rectangle, we know how many columns are here because we just pulled these two rectangles together. There's 2 plus 5 total columns there, and each one has 3 little squares. So that's 2 plus 5, that whole thing, times 3 little squares. Now of course, we're counting the same group of little squares in both cases here. So these two totals have to be the same. And that's what the distributive property tells us. This expression equals that expression. Now there's nothing special about 2, 3, and 5 here. We can do the same thing with any 3 numbers. And that's the distributive property. Instead of 2, 3, and 5, I just write this down with A, B, and C. The distributive property tells us that this is always true for any numbers A, B, and C. Now of course, with multiplication, if you're multiplying 2 numbers, it doesn't matter what order you multiply the 2 numbers. So I can reverse this product and write it as C times A plus B, and reverse each of these two products. So this is C times A, and this is C times B. So I can write the distributive property either way. I can put the sum second, or I can put the sum first. And I can even have more terms in the sum. So for example, if I started with something like 4 times x plus y plus z, I can apply the distributive property to expand this, and we say expand when we multiply it out as 4x plus 4y plus 4z. And all I'm doing here is multiplying the 4 out here by each one of these terms. And that's what we do when we expand this product into this sum. Now if we go the other direction, if we start with 4x, 4y, 4z, we see that there's a 4 in each one of these terms. We can use the distributive property to write it back as this product. And when we do that, we say we factor out the 4 and write it as 4 times this sum here. Now, let's go ahead and put the distributive property to work with a problem. Now if you see this, you think, oh my goodness, it's going to take forever. Because you got to do all these multiplications, and those aren't real easy multiplications. But then we see, hold on, there's a 93 in each one of these products. We can use the distributive property. We factor out the 93. And we write this as 93 times the sum. We pull out the factor of 93 from each one of these products, and we're left with 21 plus 9 plus 52 plus 19. And that's a lot easier to deal with. We can add these up in our head. 21 plus 9, that's 30. 52 plus 19 is 71. 30 plus 71, that's 101. So this is just 93 times 101. And this way you can see what the product is, but we can also just use the distributive property again. 93 times 100 plus 1. 93 times 100, that's 9300. 93 times 1 gives us 93. So 9300 plus 93, well, we know what that is. That's 93. And we're done.